Welcome back to the new playlist of data engineering mastery. This is a new playlist where the oldest one was about mathematics of thinking, where we discussed about algorithms and maths. Well, within this new playlist, we'll be talking about real production pipelines, real problems, real fixes, real failures. And yeah, and by the way, I am launching a Python formation. If you wanna subscribe, you can fill in the form within the description. And yeah, without further ado, let's get started. Today is a Python episode, but not a beginner Python. This is the Python that separates engineers who write scripts from engineers who write production pipelines. 6 patterns, all with code, all drawn from real failure I have seen or experienced in production data engineering environments. So these are not framework specific. They apply whether you are writing a PySpark job, an Azure function, a Databricks notebook, or a plain Python script. Three production failure, all caused by missing one of these patterns. The connection that never closed, an engineer opened a database connection inside a processing loop, no context manager, no try finally catch when the transform function raised an exception on iteration like 14.7. The connection leaked after 500 iterations. The connection pool was exhausted. The job died. The fix was 5 lines of code, one Airbus context manager. The API call that failed silently, like a 429 rate limit response from an external API caught by a pair except. The function returned none. 10 million rows were written to the silver table as null values. Nobody noticed for a week. Revenue numbers were wrong. The fix was a retry decorator, like 15 line of code. The 15 gigabytes file loaded into RAM. An engineer called spark.read on a 15 gigabyte file and then collect to process rows one by one. The Spark driver ran out of memory. It works fine on 100 megabytes in dev. The fix, a generator that streams chunks instead of loading everything. All the three are preventable. All three appear regularly in code reviews. So let me show you the 6 patterns that eliminate them. So the pattern number 1, context manager, is the most fundamental pattern on this list. So look at the left panel, the broken version, a database connection is opened, a cursor is created, a try except block handles errors, but nobody called con.close or cursor close in a final, like in a finally block. So if transform raises any exception, the code jumps to the except block, and the connection and cursor are never closed. And in a loop, this creates one leaked connection per iteration, run like 500 iteration, 500 leaked connections. The pool is exhausted, the job is dead, so no errors in the logs. The right panel shows the fix using context manager. So 3 things to notice. First, the yield statement. So the caller gets the cursor via like with manage connections DSN as cursor. So everything before yield is set up, everything after yield is tear down. Second, the finally block, both cursor close and con close are finally. That means they always run whether the caller raised an exception or not. So third, the excepts block rollbacks and then re-raises. We do not swallow the exception. We undo any partial work and pass the error back to the caller. So the usage pattern with managed connection DSN as cursor. So the connection is guaranteed to close when the with block exists, success or failure. Then we have pattern number 2. so the retry decorator, every external call API database cloud service can fail, like transitionally a network bleep a 429 rate limit, a cold start, a temporary timeout without retry logic, your pipeline falls on the first transient error. And look at the decorator code here. So the three nested functions retry is the factory, decorator wraps the function, wrapper is what actually runs. So the for loop runs from 1 to max attempts. Inside we call the function. If it succeeded, return the result if it raises one of the specified exceptions types. So check if we are on the last attempt. On the last attempt, log the error and re-raise, never swallow away on any earlier attempt. So calculate wait time as a backoff based to the power of attempts. That gives us like 2 seconds, 4 seconds, 8 seconds between attempts. Log the warning sleep continue. 4 annotation cards. So we have func tools wraps. Without this, every decorated function shows a wrapper in your logs and stack traces. With the original function name is preserved. Exception exponential backoff like 2, 4, 8 seconds. This gives a recovering service time to come back online. Never retry immediately on failure, you will just keep failing. Re-raise on final attempt, so the caller must know the call failed. Never swallow the final exception. Specific exceptions, only exceptions, HTTP error, timeout error, do not catch exception broadly. So you will suppress real programming bugs like attribute error, key error, or name error. And for pattern 3, which is the generators, so generators for large data, the problem is in the left panel. So red lines loads the entire file into memory. If the file is 15 gigabytes, you need 15 gigabytes of RAM. The less comprehension for paginated APIs fetches all the 15,000 pages before processing a single item. The right panel shows the 2 generator implementations. So the stream CSV reads the file row by row, accumulates a chunk of 10,000 rows, then yields it. The caller processes the chunk, then chunk is set back an empty list. The memory is freed. The next 10,000 rows are read. The entire file is processed using only the memory needed for one chunk. Then the paginate API, the while loop, fetches one page at a time. Yield from data items yields each item individually. The next page is only fetched when the caller asks for the next item. Memory used, one API page at any given time. Look at the comparison panel at the bottom left, red lines. Entire file in RAM, stream CSV with 10K chunk, 10,000 rows at a time. Paginates API, one API page in RAM. So the usage is clean for chunk in stream CSV data, like 15 gigabytes CSV. Process the chunk, each chunk is at 10,000 rows, like the complexity of 10,000K. Memory regardless of the file size. Then we have the pattern number 4, like data class for pipelines configurations. So every pipeline has a parameters. The question is whether they live in a DEX or in a typed validated data class. So look at the pipeline config, 5 typed fields, source URL as a string, target path as a string, execution date as a date object, not a string, batch size as an int with a default of 10,000 and dry run as a boolean. So the post init method runs immediately after init. If batch size is 0 or negative, it raises value error with a clear message. The error happens at the construction time, not 3 hours into a job run. The field like default factory list for tags, never use mutable defaults directly. So if you write tags list equals like empty list, all instances of the class share the same list objects. Mutations in one instance after all other fields like default factory list creates a fresh list for each instance. The pipeline result has a property decorator for success rate. It's computed from rows loaded and rows extracted, so no stale data, no need to update it manually, use it directly in logs. So if success equals result dot success dot rate 1%. So this, I mean, the percent here is for the f function here. So the run pipeline function signature says everything. It takes a pipeline config and returns a pipeline result. Your ADE shows you every available field. My PI tells you if you pass the wrong type. So no dict key errors at a runtime. And then we have the pattern number 5, which is structured login. The one most engineers skip. So print is not a login. It has no level, no timestamp, no context. Login info processing 1000 row is not structured login. It produces a human readable string that is hard to query. So a structured login emits JSON. Every log record is a valid JSON object on one line. Data, dog, Splunk, CloudWatch, and Loki all parse JSON natively. No regex, no custom log parsing config, just fields you can query. So look at the JSON formatter. The format method builds a dict with like a dictionary with 6 constant fields, TS level, message, logger file, line. If the caller passed extra like arguments, those are merged into the dictionary. If there is an exception, the stack like trace is serialized as a string, so not split across lines. So why does single line matter for exceptions? Multi-line log records break most log aggregators. A stack trace that spans like 10 lines is like treated as a 10 separate log records. So by serializing it to a string, the entire exception is one JSON object. So now you can query in data dog duration seconds, like more than 30 seconds. Find slow partitions, row out of like it's smaller than row in. Find partitions with data loss, build like dashboards on these fields without any configuration. Then we have the pattern number 6, which is type hints and protocols. So the foundation of maintainable production code are the type hints and protocols. So look at the left panel, the untyped version of dev process data config loader. What is data? Could be a data frame, a list, a string. What is config? A dictionary, a data class. What should loader support? Nobody knows without reading the entire function body. So the 3 calls at the bottom are all syntactically valid Python. So no errors at right time. All 3 will fail at a runtime in different ways. So config batch as a string instead of an int produces silently wrong results for hours. So the right panel shows the typed version. So first, the protocol class data loader protocol defines the interface contract. Any object with a load df path method that returns int protocol uses structural subtyping. So duck typing with compile time checking, your like the delta loader, packet loader, and mock loader all satisfy this protocol without inheriting from it. Second, the function signature data is PD data frame. Config is pipeline, is like pipeline config. Loader is data loader, returns pipeline results for lines that replace 1,000 words of documentation. Third, the mypy error dot process wrong type config loader. MyPy catches this at right time. Arguments 1 has incompatible type str. Expected data frame debug is caught before the job ever runs. So run MyPy in your CI pipeline. Every PR, it's free documentation that enforces itself. Now a quick reference, the right pattern for the right problem. So the pattern number 1, context manager triggers anything that must open and close DB connections, file handles, logs, temp directories, use context manager or implement enter and exist. Pattern number 2, retry decorator trigger any call to an external system, API calls, DB queries, cloud services, exponential backoff, specific exception types, re-raise on failure. Pattern number 3, generator trigger data larger than available RAM, large file reading, paginated APIs, streaming transforms, yield instead of return, complexity of chunk memory regardless of data size. Pattern number 4, data class config trigger functions with 4 or more parameters, pipeline config results object job parameters replace dictionary, validates in post ine the property for derived values. Pattern number 5, structured login trigger. So for any log that might need to be queried, production pipelines, batch jobs, API calls, JSON lines, consistent fields, duration like rows in, rows out, etc. And for the last patterns, the type hints and protocol trigger, any function called from more than one place, shared like utilities, pipeline interface, loader, abstractions, run mypy in CI, protocol for duck typed interface contracts. So 4 takeaways to take. 1. Context manager guarantee cleanup. 2. Retry decorators make external calls resilient. 3. Generators process large data with constant memory. 4. Data class replace dex configs, type field, post init validation. So drop a like if this was useful and tell me in the comments which one of these 6 patterns was like new to you. The structured login one is the one most engineers skip until they have to debug a production failure with no queryable logs. So that's it for this playlist. I hope you enjoyed it along this journey, and thank you for your attention, and adios.